Go outside and just flap your arms through the air. Your neighbors will probably think you're crazy and you can't see what you're doing, but you're actually creating complicated and chaotic motions through the air. In other words, you creating turbulence. It's something you probably don't think about unless you're riding a plane, but its effects can be seen everywhere, from atmosphere to the ocean to the blood in your veins. Turbulence is literally all around us. And it's also a mystery because turbulence has puzzled humanity for over 500 years.
Since Leonardo da Vinci first visualized turbulent flows, we still don't really have an agreed upon definition for turbulence. What we do have is a set of characteristics, in other words, a description for turbulence that helps you recognize it when you can see it. First, let's start off with what turbulent flow is not. If you turn your faucet on slowly, you'll see this type of flow. This is known as laminar flow. Unlike turbulent flow, it's calm and smooth, and it's characterized by particles flowing in parallel layers. If you increase the velocity of the water, it'll transition to turbulent flow. This transition was the subject of Osborne Reynolds' 1883 water in a pipe experiment. Reynolds examined how different flow velocities affected water flow in a pipe. And due to the fact that water is clear, Reynolds injected dye in order to see his experiment. What he saw was that at lower velocities, the dye layer remained intact throughout the entire length of the tube, while at higher velocities, the dye layer reached a certain point, broke up, and then diffused. Reynolds concluded that this breakup point was where things went from smooth to turbulent. From his experiments, Reynolds derived the Reynolds number, a dimensionless quantity used to predict the onset of turbulence. It relates the fluid's flow speed to the diameter of the tube to the kinematic viscosity of the fluid. This means at high Reynolds numbers, where the velocity is high or the viscosity is low, turbulence is very common. Reynolds' experiment gives us two descriptions of turbulence. 1. Turbulence is diffusive. You saw that the dye diffused throughout the length of the pipe. 2. Turbulence occurs at high Reynolds numbers. And you may not have realized it, but we've already gone over a third characteristic. Turbulence is complicated and chaotic in nature. Lastly, turbulence is dissipative, meaning that it takes in energy at the highest level, transitioning from large swirls to smaller and smaller ones as energy is consumed. These swirls are known as eddies and vortices, and are also a characteristic of turbulence. Eventually though, with no new kinetic energy, turbulence will die away.
Turbulence is a classic mystery, just waiting to be solved. In fact, there's a $1 million prize out there for anybody that can solve it. Now that you have your own clues, maybe you should do some investigating. Who knows, you might come across something big.